All right, so first thing is always to draw your free body diagram. So at the bottom of the yo-yo's loop here, the free body diagram should have a gravitational force downwards and then tension force upwards. Notice that the tension is greater than the gravitational in order to have that inward net force. So next part is to write our centripetal force equation. Centripetal force is equal to the net force acting radially. So we're going to define up as the tension, down as gravitational. So it's going to be the tension force minus the gravitational force. So overall we have Fc is equal to Ft minus Fg. Next step is to use our centripetal force equation. So we have that Fc is equal to mass times the velocity squared divided by the radius. So we can actually quantify Fc here by plugging in what we know. 0.125 kilograms for the mass, 5 meters per second for the velocity, don't forget to square it, divided by the radius, 0.75 meters. So do a quick calculation on that. I came up with 4.17 newtons here. Remember, force is always in newtons. And then this is our centripetal force. So this is basically the net force that we've seen before. We're trying to solve for here the tension. That's what it asked us for. So we need to also quantify Fg here. So I'm just going to rewrite this part, but I can plug in that the overall net force or centripetal force needs to be 4.17 newtons. I don't know the tension. And then the gravitational force, remember you can always quantify as the mass of the object times 9.8 newtons per kilogram as long as we're on Earth. So here, go ahead and plug in the mass and quantify. Now we just need to add it to the other side. So we're going to add 1.225 to the other side, and we end up with the tension force is equal to 5.395 newtons.